Good day, students. In this video, we will focus our discussion on solving problems involving distance formula. And also, we will try to prove geometric figures using the distance formula. So first of all, let us try to define first distance formula. Distance formula specifically measures the distance between any 2 points with the coordinates x sub 1, y sub 1, and x sub 2, y sub 2, which is given by the formula b is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. Now let us have example number 1. In example number 1, we are asked to find the distance between the points 2, 6 and 5, 2. Now these are two given points. So first, let us try to identify the given points in the problem. So we have p sub 1, which is 2, 6, and p sub 2, which is 5, 2. Now if we are going to plot that in our Cartesian plane, you have the first point at 2, 6, and the second point at 5, 2. Now what we will be looking for is the distance between the 2 points, the straight line that can be drawn from point 1 to point 2. Now to solve that is first, we have to recall our formula, which is shown here. Next is we identify the values for our x sub 1, which can be taken from the p sub 1, and also our y sub 1 from the same point. And on the other hand, we have our x sub 2 from the second point and y sub 2. So what we are going to do is we are going to substitute these values in the formula. So that becomes b is equal to the square root of the quantity of 5 minus 2 squared plus 2 minus 6 quantity squared. Next is simplify the right hand side following the PEMDAS rule. So first is we are going to simplify what's inside the parentheses. So 5 minus 2, that is 3, and 2 minus 6 is negative 4. Next is perform the operations involving exponents. So we have 3 squared, which is equivalent to 9, and negative 4 squared, which is positive 16. Adding 9 and 16, we will have square root of 25. Now square root of 25 can be simplified to 5, and that means that the distance between 2, 6 and 5, 2 is 5 units. Let's proceed to the second example. On the second example, we are asked to find the distance between the points 3, 2 and negative 5, 4. So again, we have to identify the points from the problem. So we have the first point 3, 2 and second point negative 5, 4. Next is we are going to plot these points in our Cartesian plane. First is you have 3, 2. Next is you have negative 5, 4. Next is we are going to find the distance drawn from the first point going to the second point. So again, recall the formula. Next is substitute the values of x sub 1, y sub 1, x sub 2, and y sub 2 on the formula. So that is x sub 1 is 3, y sub 1 is 2, x sub 2 is negative 5, and y sub 2 is positive 4. So substituting these values, we'll get the square root of 3 minus negative 5 squared plus 2 minus 4 squared. Next is to simplify everything inside the parentheses. So 3 minus 5 becomes 3 plus 5. Now perform the operation 3 plus 5 and 2 minus 4. 3 plus 5 is 8 and 2 minus 4 is negative 2. Next is perform operations involving the exponents. And that becomes square root of 64 plus 4. Simplifying 64 and 4, you will get square root of 68. 68 is not a perfect square, so therefore we cannot extract a whole number. But what we can do is to get a perfect square factor from 68, meaning we express 68 as product of two numbers, wherein one of the factors is a perfect square, and that is square root of 4 times 17. Now we get the square root of 4, so that becomes 2 square root of 17. Therefore, the distance between 3, 2 and negative 5, 4 is 2 square root of 17 units. Now we will start with example number 3. For example number 3, show that the points negative 7, 1, 5, negative 4, 10, 8, negative 2, 13 are vertices of a square. So first and foremost is we have to identify our 4 points, which are stated on the problem. So you have point 1, point 2, point 3, and point 4. Next is we are going to plot these points in our Cartesian plane. The first point, negative 7, 1. The second point, which is 5, negative 4. And the third point is 10, 8. And the fourth point is negative 2, 13. Next is we have to draw the lines that connect these points. So you have P sub 1 to P sub 4. Next is we have P sub 4 to P sub 3. Next you have P sub 3 to P sub 2. And lastly, you have from P sub 1 to P sub 2. Now, if you will look closely at the figure that is drawn in our Cartesian plane, though it looks like a square, we cannot conclude that it is truly a square without showing a mathematical proof. So how do we do that? Now, if we talk about the square, what we know is that all sides of a square are of the same measure. So what we have to prove is that P sub 1 to P sub 2, P sub 1 to P sub 4, P sub 3 to P sub 4, and P sub 2 to P sub 3 have equal measures. And to do that, we have to use the distance formula. So first, let's try to find the distance from P sub 1 to P sub 2. Now, if you will look at our given points, P sub 1 has the coordinates negative 7, 1, and P sub 2 has the coordinates 5, negative 4. So this will be our x sub 1, this will be our y sub 1, this is going to be our x sub 2, and this is our y sub 2. Now, substituting that in our formula, the distance formula becomes P sub 1 to P sub 2 is equal to the square root of the quantity of 5 minus negative 7 squared plus the quantity of negative 4 minus 1 squared. Next is we are going to simplify what's inside the parentheses. So that becomes 5 plus 7 squared plus negative 4 minus 1 squared. So performing 5 plus 7, that gives you 12, and negative 4 minus 1, that gives you negative 5. So simplifying 12 squared, that is 144, and negative 5 squared is 25. Adding 144 and 25, you will get square root of 169. And square root of 169 is 13. Therefore, the measure of the side from P sub 1 to P sub 2 is 13 units. Now, let's proceed to finding the measure of another side, which is P sub 1 to P sub 4. So, in P sub 1 and P sub 4, the points that we will need are negative 7, 1 and negative 2, 13. Negative 7 is our x sub 1, 1 is our y sub 1, negative 2 is our x sub 2, and 13 is our y sub 2. So, substituting those values in our formula, we will get square root of negative 2 minus negative 7 squared plus 13 minus 1 squared. And simplifying the values inside the radical, we have negative 2 plus 7 plus 12 squared. So simplifying negative 2 plus 7, that is positive 5. And performing the operation that involves the exponents, we will have square root of 25 plus 144. Adding the 2, you will get square root of 169. And square root of 169 is 13. Therefore, the measure of the sides of the square from P sub 1 to P sub 4 is also 13 units. Now, let's proceed to finding the measure of another side of the square, which is from P sub 3 to P sub 4. So, in P sub 3 to P sub 4, the points are 10, 8, and negative 2, 13. So, the first point will be x sub 1 and y sub 1. The second point will be negative 2 and 13. So, we'll have square root of the quantity of negative 2 minus 10 squared plus the quantity of 13 minus 8 squared. So, simplifying that, we will have square root of negative 12 squared plus 5 squared. And simplifying that, we will have square root of 144 plus 25. Adding the 2, you will get square root of 169. And square root of 169 is 13. So therefore, the measure of the side of the square from P sub 3 to P sub 4 is 13 units. And lastly, we'll have the last side of the square from P sub 2 to P sub 3. So in P sub 2 to P sub 3, we'll have the points 5, negative 4, and 10, 8. So this will be x sub 1 and y sub 1. And this is our x sub 2 and y sub 2. Now substitute that in the formula, we will have square root of 10 minus 5 squared plus 8 minus negative 4 squared. Now simplifying these values, we will have square root of 10 minus 5 squared plus 8 plus 4 squared. Now subtracting and adding these values, we'll have square root of 5 squared plus 12 squared. And that is equivalent to having square root of 25 plus 144. Adding the two, we'll have square root of 169. And square root of 169 is 13. Now we already have the measurement of all the sides of the square. And what we have found is that all the sides have equal measure. So our conclusion is, since the distance between p sub 1 to p sub 2 is equal to p sub 1 p sub 4 and is also equal to p sub 3 to p sub 4 and is equal to p sub 2 to p sub 3, then the points negative 7, 1, 5, negative 4, 10, 8, negative 2, 13 are vertices of the square. So our problem here is, we have to show that the points 5, 0, 2, 1, and 4, 7 are vertices of a right triangle. So first, identify the points. We have p sub 1 as 5, 0, p sub 2, which is 2, 1, and p sub 3, which is 4, 7. Next is we are to plot these points in the Cartesian plane. So first, our p sub 1, which is 5, 0. Next is we have our second point, 2, 1. And lastly, our third point, which is 4, 7. Next is we are to draw the lines that connect these points. So we have a line from p sub 1 to p sub 2, p sub 2 to p sub 3, and p sub 1 to p sub 3. Now to prove that these points are vertices of a right triangle, the lengths of the sides should satisfy the well-known theorem, which is the Pythagorean theorem. So first of all is we have to find the lengths of the sides p sub 1 to p sub 2, p sub 1 to p sub 3, and p sub 2 to p sub 3. Let us find first the length of the side from p sub 1 to p sub 2. First is let's recall our distance formula. Next is we are to define our x sub 1, y sub 1, x sub 2, and y sub 2 from the given points. P sub 1 is 5, 0, where 5 is x sub 1 and y sub 1 is 0. For the second point, x sub 2 is 2 and y sub 2 is 1. Then we have to substitute these values on the formula. So the formula becomes p sub 1 to p sub 2 is equal to the square root of the quantity of 2 minus 5 squared plus the quantity of 1 minus 0 squared. Next is to simplify the values inside the parentheses. So that becomes square root of negative 3 squared plus 1 squared. Next is to perform the operation involving the exponents. So we know that negative times a negative number becomes a positive number. So you have square root of 9 plus 1. And square root of 9 plus 1 basically gives you square root of 10. Therefore, the length of the side from p sub 1 to p sub 2 is square root of 10 units. Now we already have one side of our triangle. So next, let's proceed to the length of the side from p sub 1 to p sub 3. So that is, first, write down our distance formula. Next is identify the points associated on the side from p sub 1 to p sub 3, which are p sub 1 you have 5, 0, and p sub 3 is 4, 7. Substitute the values. For x sub 1 you have 5, y sub 1 is 0, x sub 2 is 4, y sub 2 is 7. So next, the formula becomes square root of 4 minus 5 squared plus 7 minus 0 squared. Simplify the values inside the parentheses. We will have square root of negative 1 squared plus 7 squared. Simplifying the expression inside the parentheses, we will have square root of 1 plus 49. So what we have is square root of 50. Now square root of 50 can be simplified to square root of 25 times 2. Getting the square root of 25, we will have 5 square root of 2. Therefore, the length of the side p sub 1 to p sub 3 is 5 square root of 2 units. Now we already know the lengths of two sides of the triangle. Next is we will proceed to finding the length of the side from p sub 2 to p sub 3. So to do that, first is we recall our distance formula. Let's figure out the points associated to the side p sub 2 to p sub 3. So in our p sub 2, the coordinates are 2, 1, where 2 is x sub 1 and 1 is y sub 1. And p sub 3 has the coordinates 4, 7, where 4 is x sub 2 and y sub 2 is 7. So let's substitute these values in our formula. So we have square root of 4 minus 7 squared plus the quantity of 7 minus 1 squared. Simplify the values inside the parentheses, you will get square root of 2 squared plus 6 squared. Simplifying them, you will get square root of 4 plus 36. Next is adding the 2, you will have square root of 40. Simplifying square root of 40, you will get square root of 4 times 10. Extracting the square root of 4, you will get 2 square root of 10. So therefore, the side p sub 2 to p sub 3 has a measurement of 2 square root of 10 units. Now we are done getting the measurement of the sides of our triangle. Next is we'll try to see if this will satisfy the Pythagorean theorem. Now if you will look closely, p sub 1 to p sub 2 has measurement of 10. P sub 1 to p sub 3 has a measurement of 5 square root of 2. And p sub 2 to p sub 3 has a measurement of 2 square root of 10. Now we already have the measurement of the sides of our triangle. Now we will substitute these values in our Pythagorean theorem. Now if you will compare it to the figure, our C is represented by p sub 1 to p sub 3. Our A is represented by p sub 1 to p sub 2, and our B is represented by p sub 2 to p sub 3. Now let's substitute the values. So this becomes 5 square root of 2 squared is equal to the quantity of square root of 10 squared plus the quantity of 2 square root of 10 squared. Next is simplifying each values, so you will have 25 times 2 is equal to 10 plus 4 times 10. So that becomes 50 is equal to 10 plus 40. Simplifying the right hand side, you will have 50 is equal to 50. Since both sides are equal, therefore we can say that the lengths of the sides of the triangle satisfies the Pythagorean theorem. And if that's the case, we can say that the points 5, 0, 2, 1, and 4, 7 are vertices of a right triangle.